Hi there, today I would like to talk about this printed circuit board Honeywell W4115, how it is connected to a burner, and also this gas valve, it is that type of gas valve which can be modulated, so that printed circuit board will control the valve. Also I want to show you that you have a choice to use a programmable logic control or a simple thermostat on designing heating controls. So I can talk to you about some mistakes done by gas engineers and by the control engineers. So number one, let's see how this printed circuit board works. As you'll see, this printed circuit board needs to have a power supply, live, neutral and earth. Just you can see above. Also I designed a switch that will bring power to this printed circuit board, but if you bring power to this printed circuit board will do nothing. You will be just a powered up printed circuit board. However, I want to show you how it is working. Now you have another set of wires just under the power supply, and this wire are meant to bring to this printed circuit board relay. It's a black relay, as you'll see, where the wires goes in, and that relay will close or open the circuit, allowing the signal to be returned to either a burner or a programmable logic control. Underneath the printed circuit board you have two wires which are low voltage that will go straight into these actuators of the gas valve I showed you before. That will control the gas valve's capacity, and this printed circuit board will take a signal from a programmable logic control, from a building management control, or for a special thermostat with the capability to supply not to 10 volts or 4 to 20 milliamps. So this printed circuit board have the capacity to control the gas valve actuator. Now these two wires on the right hand side, lower side, are the wires which will come from the building management control, from the programmable logic control, or from a thermostat that have the capability to supply not to 10 volts or 4 to 20 milliamps to this printed circuit board. So it is very important. You'll find out a little bit later. It is very important to understand this signal, because that will help you to understand how this printed circuit board it is working. Now if you look here, we have the power supply not enabled, and also the signal to the printed circuit board contactor it is not enabled. So this is kind of safety wiring. That signal can come from a programmable logic control, or from a building management control, or can be even a switch. Could be connected in series with a group of alarms like fire alarms, supply fan differential pressure switch, or any other type of alarm like high temperature limit, etc. But let's see how this printed circuit board works. When you will apply power to this printed circuit board, as you will see on the top, on the left hand side, you have live, neutral and earth. This printed circuit board will become alive. As you will see, you have the fuse on the top where it's written 240 volts, and then the electricity continues journey to the transformer, which is powered up, and underneath the transformer you have a low voltage fuse, which also shows you that it is powered up. At this stage, this printed circuit board it is standby, but it does nothing. You see the signal to this relay, the little black relay on the right hand side top on the printed circuit board. The power doesn't reach the relay's input, so even if the relay will close, there will be nothing to continue. So this is a safety kind of wiring. So even if the printed circuit board will be damaged and that relay will close the circuit, there will be nothing to transmit. There won't be signal because the signal is interrupted before the relay. So as I said, that can be connected to health safety feature like high limit temperature switch, fire alarm, etc. Now when you will close that circuit and you will have power to that relay, still the signal will not continue its journey because that relay is not enabled. The printed circuit board will never enable that relay until the building management control or the programmable logic control or the thermostat will provide 4 to 20 milliamps or not to 10 volts to this bottom right hand side wires. That's a signal which will demand heating, and you will see how this will work. So at this stage, this printed circuit board is enabled, and the signal that's supposed to activate a burner, it is on standby. Now when we'll apply not to 10 volts or 4 to 20 milliamps to this printed circuit board, normally the relay will be activated, but in the same time the control capacity will be activated. You see in the left hand side at the bottom you have gas valve control capacity, which will manipulate the actuator. I work for Marks and Spencer. I saw a couple of mistakes in which the actuator is manipulated, but the fan, it's run constant airflow. As you'll see now on the right hand side on the top, the relay closed, and it closed the circuit and the signal continues its journey. Either way, you can go to a burner directly to enable a burner, or you can go to a programmable logic control that will tell to the programmable logic control or to the building management control that the printed circuit board is healthy, and then the BMS will enable further, will instruct the burner what to do. As you'll see now in this picture, the capacity controller is activated. You will be actually instantly activated when the relay will close. This capacity control will be also activated, and the printed circuit board will start to have a control capacity on the gas valve. And this is about this printed circuit board. You will see it here now. It's fully functional. And I think you have to pay a lot of attention when you replace this printed circuit board, because I caught a lot of electricians, control engineer, or even gas engineer making huge mistakes. You see on the right hand side on the top you have some potentiometer which will allow you to adjust the minimum and the maximum voltage where this printed circuit board will allow this relay to close a circuit and to enable the burner. If you make a mistake, as an example, to allow this relay to be closed when you will apply less than 1 volts, then with some occasion the outdoor humidity or any little tiny electrical leak through these semiconductors could enable that relay, and the burner can be activated without this printed circuit board to get instruction to run the burner. So you really have to pay a lot of attention to these potentiometers. You will set up the dead band in which this boiler will run. You will set up the minimum voltage in which this printed circuit board will enable the burner via that relay, which is marked with yellow, where you'll see the signal coming in and going out. And you really have to pay attention, because with some occasion I found one air handling unit which runs on Reznor burner fitted on Hale somewhere in Cornwall, and this printed circuit boards were enabling the burner even if the programmable logic control or building management control was sending voltage to it. I mean, the voltage was 0.5, probably a tiny leak enabled this burner without the supply fan, and that could lead in a disaster. Otherwise, you also have towards the middle of the PC board control 2 dip switches that will allow you to set up this printed circuit boards to run on 4 to 20 milliamps or not to 10 volts. This is simple as such. Now going further, let's see how this can be integrated. I made a couple of mistakes when I did this, because the Microsoft just decided to change the Paint program, and that annoyed me a little bit. I couldn't find the tools and I made a little bit mistake, but I'll explain the mistake I did. Now you can see in this picture that this printed circuit board, it is integrated onto this building management control. Now this building management control have the capability to enable this printed circuit board, and also not only to enable but to control its capacity. See, to the lower side you have an analog output on this building management control, which sends this information into the programmable logic control, and that will be not at 10 volts or 4 to 20 milliamps, and this is the control capacity. If you'll do this using a building management control, it's great, because the building management control can collect a lot of data from many rooms, because you can fit into these building management controls many probes which collect data in relation to rooms temperatures, and then the building management control will enable this printed circuit board that will activate the burner. I made a mistake, as I see neutral and earth shouldn't be connected to this PLC. It's not a technical mistake, it's just a painting mistake I did. So please ignore that. Neutral and earth won't be connected. This go just under this BMS, but I didn't realize that someone can believe that is going actually inside the BMS. It's not. So the blue and the green one, it is not going into this BMS. Only the top one, which is gray, and the bottom ones, which enables the printed circuit board. Now I use the picture of the real valve and I show you where the wire goes. On the top you have an actuator, and this actuator controls the capacity of this gas valve, allowing more or less gas to pass by. But I just want you to understand, this is not the main gas valve. So if the burner will not open the main gas valve, it doesn't matter what this printed circuit board does moving this actuator. There won't be gas through this gas valve at all. So what you will see here is just a control capacity, low voltage control capacity, and has nothing to do with the safety, because if the main gas valve will be closed, it doesn't matter how you will actuate that feature, there won't be gas at all into this through this gas valve. Going further, this is a Brahma burner control. I will not spend too much time explaining how the Brahma control works, because I have another video which shows in very detail how this Brahma burner control works, and you can even see how to open that Brahma controller and to check dry joints or bad soldering, because I opened a lot of them, and rather than spending money on new ones, I just solder this dry soldering and dry connections, and they work like new. Now this Brahma controller, it's also connected to this building management control, and I found with a lot of occasions this type of wiring, you don't have necessarily to connect this Brahma controller to the programmable logic control. This can be enabled directly from this printed circuit board. If you'll see that relay I was talking to you earlier, when the PLC send electricity to that relay, and also when the PLC or building management control BMS send not to 10 volts and enable that relay can bring power straight into this Brahma directly. The engineer choose instead to return the power into this building management control is because in this way, if you monitor remotely this printed circuit board, you will know if this printed circuit board works. I mean, just imagine you will supply not to 10 volts to the bottom on the right hand side, and then the signal will be returned and registered by the BMS, and then you will see on your laptop that the printed circuit board it is healthy. Now this is the way the technician choose to wire this system. As I said, I'm not going to spend too much time on Brahma controller. I think as an engineer you know how the gas valve work, and I just explained this printed circuit board how it works. Now in the beginning how this system will work, first the building management control will be enabled and you will check all the safety. If all the safeties are okay and everything is in place, then this building management control will power up this printed circuit board. Will send the power, and then this printed circuit board will be powered up, and the system will be on standby. If the system it is on standby and there are not faults, the building management control will send the signal to this printed circuit board's relay, but the signal will not be returned into this BMS until the not 10 volts will be present to the lower side of this printed circuit board, and until then the system remain on standby. I wonder if you can see the relay on the right hand side. It's painted with black. You can see the red arrow inside the relay where the electrical signal stop, because the relay it is not activated by the printed circuit board, so it's not going further. To go further, this relay have to be enabled, and the printed circuit board, as I said, will only enable that relay if on the lower right hand side you will have this not to 10 volts or 4 to 20 milliamps signal active. Don't forget when I told you about this potentiometer, you'll decide the value and it will start. So now if you look to the lower side, I enabled this printed circuit board. I provide as an example 5 volts or somewhere in between 3 and 10 volts, and when I did this, automatically the control capacity to the gas valve became active, and in the same time another signal from the printed circuit board goes to this relay, and if you look now, the relay it's active, and it sent back the signal to this building management control. Please be aware that that signal can go directly into the Brahma controller, into the burner controller. It is a choice. It's how much do you want to monitor the health status of your heating system. So the technician choose to go through this building management control because he want to monitor very in detail the health system of his burner. Now the building management control send a signal to the Brahma controller. It brings power to the Brahma controller. But even if the Brahma controller got power to L1, it doesn't mean that it will automatically start. For this Brahma controller to start, the connection in between number 3 and number 7 of the Brahma controller must be short-circuited, must be closed. So as you'll see, there are 2 wires that goes back into this building management control, and they are connected to an output, which means there's only a voltage free relay, and this relay will close the circuit, will act like a thermostat, and then the Brahma controller will be enabled. So when the Brahma controller it is first powered up, you will send the signal to this building management control. You see one of these wires, I think is number 7, it is orange and it goes into this building management control, but the signal is not returned yet. When the heat is on demand, the building management control will close the circuit, and you'll see just now the other cable become orange, which means the circuit is closed. Now the circuit is closed and the Brahma controller will start to initiate the heating protocol. It will start to initiate the ignition. First, it will start the flue fan. The flue fan, it is provided with a differential pressure switch. Now the Brahma controller will send an input to this differential pressure switch and it waits for it to return. When the fan will accelerate, if the differential pressure switch is healthy and the fan is healthy and the pressure into the flue it is okay, then the differential pressure switch will close the circuit and will send the signal back to the Brahma controller. Look into the right hand side. All 4 arrows now are red, which means the system is healthy. So if the system is healthy, then the Brahma controller will jump to the next sequence. It will enable the ignition. You got a spark plug with a very high voltage will create an electrical discharge like a flash on the sky, and then automatically the gas valve will be enabled. The gas will pass by through this ignition to this electrical voltage discharge and will be ignited, and then you'll have a flame. While you have that flame, there is a flame monitoring device. It could be ionization probe, UV probe, it could be any type of probes, but in Brahma controller case it is an ionization probe. So the ionization probes just start to record that flame, and if the flame is okay, the half rectify wave will be read by the printed circuit board of the Brahma controller, actually by the Brahma controller, and then the Brahma controller will hold on the gas valves, and then the heating system will work without any problem. If you will be any problem with the gas due to the wrong ventilation, incorrect adjustments, or any other type of fault which will disturb the light, the flame, then the ionization probe will cut off the flame. But if not, then the ignition probe ignition protocol will be turned off, and then the gas burner will run as normal. Guys, I did many other videos which explains how boilers works, what will be the control philosophy, what will be the sequence to run a boiler, and the main thing is that before you repair something, I think first you have to understand how that something works. Now let's say in these circumstances you don't want to waste your money on a expensive building management control or on a programmable logic control. You only want to use a thermostat and probably probe that have the capabilities to supply not to 10 volts or 4 to 20 milliamps directly to this printed circuit board. Well, in this case you have to change a little bit the wiring, if you'll see here. Now the not to 20, the 4 to 20 milliamps or not to 10 volts will be connected straight to this printed circuit board to the bottom. Then you have a switch which will provide power to this printed circuit board, and also the same switch will provide the power to this little relay onto this printed circuit board. Then you have to install some safety in series. When you first start the timer, the signal will try to reach the printed circuit board and to the relay which is on the circuit board, printed circuit board. So this is all good. You have a timer, and because you like safety, you will not only provide the signal to that relay onto the printed circuit board, actually you will provide power to the circuit board. So when the timer will finish its duty, will cut the power to this printed circuit board. So this way it's much safer. If you have any leak or let by of electricity, you won't have any problem. But then when you will enable the timer, instantly you will have 3 alarms that will be checked because they're in line with that signal. So you'll have a fire alarm, you'll have a high temperature alarm, you'll have a differential pressure switch of the supply fan. You can have many safety alarms. If you're a control engineer, obviously if you use the logic gates, you'll use an AND feature. And if you are an electrician, obviously you will say that this is a serious connection. So we can interrupt the signal to any point. All the alarms should be okay. You should have no alarms, or otherwise the signal will not reach this printed circuit board. If all the alarms are okay and you don't have any trouble, then the signal will reach the relay which is on the printed circuit board, and the circuit board also will be powered up because the timer will give power to both, to the relay and to the printed. So you'll have a loop in between L1 of the printed circuit board and the relay input. So if the probe which is outside will demand heating because outside is too cold, then it is easy. You will enable that relay, and you will enable the control capacity of the printed circuit board. It's easy. You will act just like a programmable logic control. You will have the capability to increase or decrease the voltage, or increase or decrease the amps as per the temperature outside, because you might use a thermoresistor with a repeater or with something that can convert that signal in not to 10 volts or 4 to 20 milliamps. And even if the Brahma controller will be enabled and the control capacity will be enabled, it doesn't mean the Brahma controller will initiate the heating, because you see you have a thermostat, and the thermostat is supposed to close the circuit between 3 and 7. And at the moment this system, it is on standby. Outside is very cold, the timer is asking for the boiler to go, but maybe inside your home it is warm enough. You have a nice isolated home and you do not demand heating. That's the thermostat, which says, okay, look, you're on standby just in case the temperature will drop. So if the temperature inside your home will start to drop, then you will the thermostat will enable the signal to Brahma controller, will close the circuit between 7 and 3, and then the Brahma controller obviously will initiate the heating protocol. So as you'll see here, I just put the arrows. You see the arrows. Now the signal goes and is returned to the Brahma controller, and the Brahma controller understand that there is a heating demand, and it will start the gas ignition protocol. So this is all about this burner. It's not a big deal. And if you want to know more about Brahma controllers in detail, how they work, I have a video about this that shows you how they will initiate the flame and so on. What can I say? Thanks a lot for watching this video. My intention was to explain as best as I could this printed circuit board and its capacity. It can be used with any burner. So technically this printed circuit board can have some of its function redundant. As an example, you don't necessarily have to use this control capacity of a gas valve. I still have some problems with this because some engineers and designers make mistakes because they run the gas valve without how can I say, they control the gas valve capacity without modulating the fan, and then I have a lot of fresh air excess. I lose the capacity of the HUs, and this is not something that it is approved or according to this gas education I got, I understood that this is a bad thing to do. So thank you for watching my video, and remember, this is a free video. I don't have any incomes or dreams about making professional artistic YouTubes. I don't try to teach you how to do your jobs. I'm just sharing some of my experience with you, and I read a lot of and I'm watching a lot of YouTubes, trying to learn as much as I can, but in the same time I want to give something back. And of course I'm making a lot of mistakes. Any criticism is pretty welcome. That shows people really care. And have a nice weekend and easy job, guys. Thank you.